Hi, my name is Samantha Bos, and I'm with the University of Texas at Austin. And today I'm here with Project STAIR to talk about statistics. So first, let's talk about some key statistical concepts. Statistics is unique from mathematics in that context is critical in statistics. The shape of the data, for example, the dimensions of the data, include the distribution of the data, the center of the data, and the way the data is presented in different graphs. When teaching new graphs, it is important to spend time on teaching students both how to construct new graphs as well as how to analyze the data presented in each type of graph. So you can see here when we're talking about categorical data, possible graphs can include object graphs, picture graphs, bar graphs, and pie charts or circle graphs. When we're talking about continuous data, we can use stem and leaf plots, line plots and dot plots, histograms, and box plots. And when we're talking about bivariate data, we can use line graphs, scatter plots, and best fit lines. There's lots of options that we have, and it's important to talk to students about why we use different graphs depending on our data. So let's look at some common challenges that students regularly face when trying to understand statistics and some potential strategies to help them out. If a student, for example, struggles with posing a question that is statistical in nature, let's emphasize the importance of context in statistical questions and that they can be only answered by collecting data. For example, based on past growth patterns, which plant do you expect to be the tallest in 1 month? A non-example would be if a plant grows 1 inch a week and is currently 5 inches tall, how tall will it be in a month? That one we don't need to collect data, we can just solve it algebraically. What if a student struggles with determining categories for grouping data? Well, a potential solution would be to brainstorm or provide possible categories and play games in which students must identify shared attributes between objects and create their own rules or categories to classify objects. What if they struggle with sorting objects based on more than one rule? Well, we really need to make sure that we're scaffolding instruction so that students initially sort objects by one visible attribute, and then have students state the sorting rules that include more than one attribute. What if a student struggles with looking at the data set within a graph as a whole rather than a single data point? Well, we need to explicitly ask questions about the shape of the data. We can draw a line or curve connecting the data points to illustrate the general shape of the data. We can also ask students to compare the shapes of 2 different graphs. If students are struggling with dealing with 0 when creating a bar graph, we can explicitly include categories for which there may be no applicable objects. We can scaffold instruction and discuss with students why there still needs to be a space for a category with no objects. And we can ask students to count the bars and count the survey items with us. And what if they struggle with understanding the scale in pictographs? Well, we can, again, explicitly teach students that there is not a one-to-one correspondence between the pictures and the number of objects counted. We can also focus on skip counting for each category. What if students struggle with understanding the meaning of the bars and the X and Y axis in histograms? Well, we want to compare those bar graphs to histograms and explicitly teach analysis and interpretation of histograms. If students struggle with understanding that each quartile has 25% of the data points in each box plots, then we can again go back to comparing to what they know. Let's compare those box plots to histograms. Let's teach the meaning of the word quartile. Let's discuss variability and how each section has the same number of data points. And if students struggle with selecting the best graph for the data, let's provide them with a list or menu of potential options for students to choose from when deciding which type to graph or create. When have students provide a reason for choosing a particular graph before they begin graphing, and ask students to reflect on whether the graph they chose was the best option to represent the data. It can be beneficial for students to start thinking through statistics by following a 4-step process. First, we start by formulating the question or questions. We have to collect appropriate data, We analyze that data, and then we interpret the results. Thanks for watching this STAIR-tailored video on statistics. Be sure to subscribe and check out our YouTube channel for more great videos. Thanks, and I hope to see you soon.